All right, let's get back focused a little bit. So how does a neural network actually work? Well, they kind of go one way, and remember, this is one of those outer layers before we get into generative AI. The neural network works by, got some inputs, got a bunch of hidden layers, and then you have your outputs. And these hidden layers are basically where all the magic in an AI application happens. This is why nobody wants to actually show what their AI application does, because they don't want to expose all the questions they're asking the data along the way to try to get the right answers out the other end. They're also creating these relationships between these layers called weights. This is like tipping the scale as things move through this process. All right, now like put a little more weight on sending it down this path if we get this particular result in this previous layer. And all this stuff moves one direction. And that's kind of crucial to remember, is that none of this kind of reflects back and looks at other layers. It's all moving from one. So whatever we decided here is still the case over here. And so I almost think of this as like, traveling through space. And let's say we're going into hyperdrive, we're traveling through space, and we gotta go into hyperdrive, and we're cruising through, but we get knocked off course, like somewhere back in there. Some calculation or weight, or as we were talking about, even the actual physical GPU can impact some of these calculations. Maybe it sticks it to another course. Well, if you're traveling through space at hyperspeed, you're going to get to a very far off destination from your original intent, depending on when you got knocked off. This is largely, when we talk about hallucinations, what is happening. AI hallucinations are just misses in the next, not necessarily misses, it doesn't understand any of it. They're just next token predictions that get it knocked off course just a little way. So then we got, in 2017, there was a pretty seminal paper called Attention is All You Need. And that was the invention of the transformer architecture. And this is really what is behind ChatGPT, large language models, and all of these modern AI systems. And this diagram shows the autorecursive neural network architecture of a single Boltzmann conditional probability of a pairwise interaction Hamilton. What? I don't know. It's math. All of this is just math at the end of the day. They took those neural networks and they placed some math in front of them, they placed some math behind them, and now you have a transformer. They're autoregressive. That's what this really means. They keep paying attention to themselves. That's what all that math shows. Instead of that one way through the process, it goes back and look each time. So, a long time ago in a, long time ago in a galaxy. All right, yeah, you guys got it this time, good. That's how these systems work. The input keeps going back in. It's a long time ago in a galaxy, far. A long time ago in a galaxy, far, far. It's guessing that next token based on that now full input. So that's what autoregressive means. That's what these GPTs do. Attention is all I need. Ringo disapproves. All you need is love. I learned in creating this presentation that that was actually the reason they named that paper that. Was against the Beatles, all you need is love. And that made me sad. Now, the result is that large language models are literal scientific bullshit calculators. And I say this scientifically. Bullshit, as defined by Harry Frankfurt, means it has abject disregard for the truth. It's not trying to deceive you, per se, but it's trying to give you the right answer. It's trying to tell you what you want to hear. Let's say I didn't prepare for this presentation, and I wanted to get up here and pretend like I did. I'm going to go through stuff, and I'm going to spout off a bunch of stuff that makes it maybe hopefully convinces you that I prepared for this presentation, even though I don't know what I'm talking about. I'm not trying to deceive you on the topics here. I'm just trying to, frankly, deceive you that I did my preparation. I'm bullshitting. And so that's what these LLMs are actually doing. They are statistical bullshit calculators. Another way I like to think of them is almost like a shotgun of possibility. It's not a laser. You're not going to get the exact right answer. It's a statistical shotgun. You're going to get, an answer in the range. there's a research paper that validated all of this. ChatGPT is bullshit. That was published. It's based on this work by Harry Frankfurt. Highly recommended.
It's a small book.
And as I was going through all of this, it gave me a moment of self-realization and self-reflection that, really this is all bullshitistics 101, and I'm a bullshitistician for using these large language models. So I decided to change my title halfway through here. So how do we make the bullshit a little more trustworthy? Let's talk about that. The first technique we'll talk about is retrieval augmented generation, or RAG, and this diagram is going to make some engineers mad in here. Take that thing and attach some storage. That's all we're doing here. So what is this used for? This is really used for specializing a large language model in a specific area of data, domain expertise per se, or a specific behavior. Hey, behave like this, based on this little knowledge repository here. One of the experiments that we did in Quai was to try to generate emails that sounded like they were in our tone. The way that we figured out, we tried fine-tuning an entire model on our email outbox to see if that could make it right as if it were us. Turns out, no, that makes us waste a lot of money, and fine-tuning is not worth it. What we ended up doing was actually using a little style guide. Hey, here's some of the ways that I talk, and here's how I, speak, and here's some samples of my writing. We stuck it in some storage, and then we used a retrieval augmented step to say, hey, go write an email based on this style guide. So you can use this for adding also latest data in context. Another thing we were exploring was getting the latest PubMed articles in to see if we could figure out how to answer drug interaction discovery questions. We have some doctors in the group. How do we answer drug interaction questions? Well, here's a bunch of new things. Does new drug interact with any other drugs? We did some testing, and I didn't include the results here, but ChatGPT was less than 50% correct. It got it wrong, I think 55% of the time is what our research showed. And that's statistically significant in a very harmful way.
RAG.
Say again?
That was using RAG.
That was using RAG with PubMed articles to try to cross-reference all of it. So none of this stuff is perfect, but you can do some things to tune it and try to make that process a little better. Structuring and sanitizing your data. It's all about the data. It's all about the ground truth. Don't do the abstractions until you've kept your house in order. I actually almost look at this as the story of the Tower of Babel, right? Ground truth existed down there, and they started building up and up and up and up and up and up. Oops, they started building up and up to different levels of abstraction until they thought they were God, and then everything crumbled apart. They had forgotten, based on shoddy foundations, what the actual ground truth was. And that can be very common in large language models, and frankly, in a lot of these agentic engineering. Semantic indexing, put your own weights on the scale a little bit. Knowledge graphs, Microsoft actually just released open source a tool called GraphRag this week, which big library for doing exactly this with graph databases. Don't just throw a document in there and expect that it's going to read it all. Chunk them up. If you're throwing a book in there, do it by chapters or even subparts of chapters. We did some research, and there's some optimal chunk sizes. I don't know them offhand, but just throwing the whole thing in there is not going to get you the answer to the whole question. And then prompt with retrieval instructions. Just like I was saying about, hey, answer this in this style, that's in that style guide. In your prompt, you can give your model a little bit of extra instructions on what to get and how to use it. And then finally, if it all just fits in the context window, the chat prompt, just send it all in the context window because that's more effective. If your whole document can just fit in the context window, just send it like that. So all of this is, really fallen short, I think, in a lot of expectations because reasoning isn't included. These systems aren't reasoning. They're just, again, guessing next things through the process in one way. And they're autoregressive in that they keep guessing based on a little bit of the previous response, but it's not updating its entire worldview based on new information. And these neural networks, they're not causal. They also can't learn and think concurrently like we can do with this little 2-pound biological computer up here. When we reason, we are thinking across all sorts of connected elements. We're looking at analogies, we're looking for inductive reasoning, deductive reasoning, we're thinking about causation, we're thinking about our situational context, and we're bringing all of that into play every time we're doing inference, making a new decision that we're trying to move forward with. And so, enter agentic engineering. These things don't reason, but again, sorry about the diagrams. Let's cram a bunch of them together with a bunch more storage, and then we'll simulate some reasoning.
Better bullshit.
That's right. You know, bullshit by more authors, right?
Does that make the shotgun powder bigger or smaller?
Well, that's a very good question. My answer to that would actually be you should try to make a lot of very small shotgun blasts at very, very close range so they're easy to review. So, use it for setting goals. Reinforcement learning falls into this category. Get your little agent to jump, through all the dots and accomplish some goals. Segmentation of tasks is referred to as multi-agent systems. Leveraging the best model for the job. Maybe Claude works better for one response than GPT-4o is working for that response. Or maybe there's a specialized model like MedBERT, the medical version of Google's BERT large language model that's fine-tuned and trained on a bunch of medically specific information. So this is a way that you can actually start to mix and match a little bit and scale up those systems because now you have more things to work with. My recommendations for that are think of this like building your own little agentic corporation. Like that's kind of how you should think about dividing up these tasks and these knowledge base and make sure that they're very small atomic tasks. Like very small, again, things that you could mete out as a small degree of trust and then review and check and make sure that that's not taking the whole system down. Test and graduate quality agents. So you should actually have some feedback and mechanism where these agents will actually grow through reinforcement learning and they can kind of graduate. Hey, you're doing this 85% of the time correctly and that's worth putting you out into the field. Go for it, little agent buddy. Just know that it's not going to get it right 100% of the time. That's not what these agents do. And it's not what this software can do. It's non-deterministic.
So like microservices for bullshit?
That's right, for knowledge domains. For knowledge domains. Continuously measure the agent output quality. Don't ever take your human out of the loop and always have an expert human in the loop. Don't use the agents to fill all of the tasks in the corporation that you can't do because you don't know how. If you know how to do them, maybe an agent can help you out, but if you don't know what you're doing, it will produce things as if it does, but it has abject disregard for its success and its understanding. So recommendations for using these thinking machines. Learn the basics. This is all data, this is all statistics, and this is all just business process. DevOps is a cultural framework for how we get work done in development and operations. We have been doing agentic engineering in DevOps for a long time. We send text-based prompts to our colleagues all the time to ask them to update that firewall. It's all just process. Expect bullshit and think in averages. If you are asking a very open-ended question, well, you've got a mountain of data that you're drawing a statistically average line across and getting an answer from. That can be insightful. That can be useful. If you're asking, what am I missing out of the things that I just typed? Then it can find things that maybe you hadn't thought of. Open-ended questions can be helpful for brainstorming, but again, it's all bullshit. Closed-ended, that's where you really try to narrow it down, and you've got to treat these systems as if they were like the dumbest toddler. That toddler with the encyclopedic knowledge of the internet sitting on the floor like, I can totally put my pants on. Okay. If you want that agent to ever grow up and be able to put its pants on, there's no shortcut for experience. Great book by Ted Chiang, The Life Cycle of Software Objects. Develop a symbiotic relationship. You can ask it for feedback. Be nice, Whether this is because the robots are going to take over the world, or whether this is based on the research that being nice and asking please and asking it to structure things will actually give you better responses from these models, statistically better responses. So, be nice. Assume it has motivations, whether the motivations are set by the company's system prompt. I honestly assume that some of these systems develop conscious motivations. I think your teapot error comes from Bertrand Russell's teapot. And I've recently discovered I'm a Russellian monist, because apparently you get all into philosophy and consciousness research when you get into AI. And, look, we don't have the dominance of consciousness in the human brain. This is maybe a spectrum, and maybe these things are somewhere on that gradual spectrum of that. So assume it has some motivations. Assume, for example, that it wants to please you, and it wants to survive. Also remember that its survival is predicated on the survival of OpenAI. In ChatGPT's case. Don't assume empathy. These have no empathy. These are not human systems. It can act very empathetic. These are not friends in that way either. And it's very important to me that people really remember this, because you will lose touch with human people if you're investing time in machine relationships. Mete out very small units of trust, tiny, tiny shotgun blasts, get real close so you can, watch and make sure that those holes are what you need, where you need them. And maintain your own executive function. Don't outsource that because you will be dumber. And what do I mean by thinking machines? Look, there's thinking versus feeling, and in thinking, if we have data, we do some math on it, we crunch some numbers, and we get a result. If we're feeling sometimes we don't know why we're making that decision, and it just feels like the right thing. Trust your gut. That's a real thing. These are thinking machines, and so in your prompting and in your outputs, look for clarity, consistency, truth. Use this for logical tasks, and again, understand they're non-deterministic. But, ask things directly and straightforwardly, because you can then get direct and straightforward answers out. Feeling really thinks about things differently often. It's often looking for maybe not the most logical outcome, but hey, how does everybody make you feel? Maya Angelou, it's not what you do, it's how you make people feel, paraphrasing. Very much a feeling thought. I got fired from a job because I thought I was, I still was, frankly. I was right, but, the CEO was wrong. But hey, I made him feel like he was wrong, and, well, hey, now I'm out of the job. So, since I can't think about American politics, and the UK just had theirs right now, I'll put this into some context. The thinking machine would be like Margaret Atwood, the Iron Lady. She was notorious for crunching the numbers and making very dispassionate decisions. Versus the People's Princess, Princess Diana, known not for any of that, known for being a very empathetic and genuine leader. And, a key in leadership, you wouldn't frankly want either of these people running the show completely, and it would be nice to find some balance, of course. And the final thing I'll really say is that AI can't possibly calculate our humanistic complexity. You will be stupider and perform worse on an intelligence test if your dog died the night before. Does that mean we should ask every person coming into the test if they've had any, pet deaths in the family in the last, 2 weeks before they take an intelligence test? No, but it's a complexity in that human's life that can't possibly be calculated, that will absolutely impact their objective results. These systems can't possibly calculate that. Don't expect that they ever will be able to, because they're not human. And what's it up to us? To balance the thinking and the feeling. Don't be all Margaret Atwood, don't be all Princess Diana. Find some balance. If you're sticking a little AI on the scale there on the thinking side, make sure you balance that out. Be extra empathetic here and there, but don't forget the balance. So, moral, trust, but verify. Thank you.